Hello, welcome to the course PLC for Beginners, and today we are going to start lecture number 4, Analog Input and Output Signals and Wiring. This is going to be a very important topic, so let's start. So in the previous lecture we saw that analog signals are constant. In today's lecture our main motive will be go through the concept that how this continuous signal is read by the PLC. Also, if you remember, in the first lecture, in the lecture number 1, we have gone through different types of sensors like temperature sensors, we have the pressure sensors. So these type of sensors gives a continuous output signals. So these kind of signals are called as analog signals. So to understand the concept in detail, let's take an example of temperature sensor. Let's take an example of thermocouple. Thermocouple is a temperature sensor. From the name, we can understand then what the thermocouple is. Basically, there are two different metals, metal 1 and metal 2, and they both are jointed. And when it is heated, a voltage difference is created, and this voltage difference is our analog signal. The analog signal can be of a voltage type analog signal or current type. Generally, there is a wide range we can get the signals, but most of the cases the range for voltage is 0 to 10 volt and current is 4 to 20 milliampere. Now see, the voltage and current values are physical values, but PLC can only understand the digital values. So these values has to be converted in the digital form. So the process is very simple. We have analog signal. It's the analog signal is sent to the transmitter, or you can say transducer, and this transducer fed the signal to ADC. ADC is basically the analog to digital converters and they are inbuilt in the PLC. Now let's use another approach to understand the same concept. Assume that we have a pressure sensor which can sense 0 to 10 bar and it gives output as 4 to 20 milliampere. So first of all, our graph will be like this. This is 0 bar and this is 10 bar. This is 4 milliampere and this will be our 20 milliampere. So basically when the pressure is 0 bar, we have an output signal of 4 milliampere, and gradually when the pressure increases, the current value also increases. So when the pressure reaches to 10 bar, the final value will be 20 milliampere. Now in the PLC, with the help of analog to digital converter, so different PLC have different ranges. So we will assume a range. So let's assume it has a range of 0 to 2469 units. So now let's convert the signal to the digital form. So let's take the signals first. We have our 4 milliampere here and we have our 20 milliampere somewhere here. Okay. And we have our PLC values from 0 to max 2469. So you can see gradually the current is increasing, the values are also increasing. So assume we get a value of 1, 2, 3, 4. So it might mean that the current is around 10 milliampere. So the pressure will be 5 bar. So this is how PLC converts the signal and understand the analog signals. So at the end, the graph we will get will be 0 to 10 bar and it will be 0 to 2469 units. This will be PLC values. I'll write PLC values also here. Values. This will be analog input. signal. This is pressure. This is also analog signal. I hope the concept for converting the signals are clear. So if you have any doubt, please do ask me in comment section. So now let's move to the analog input and output PLC wiring. The analog input and output wiring for PLC can vary from 2-wire system to 3-wire system to 4-wire system to many more. So there are many different approaches to do the wiring. So I will be clearing the concept for wiring so that the video don't get too long and you don't get bored. Once the basic concept is clear, you can do different type of wiring very easily. So to explain the concept, I am going to use PT1. Basically, it's the current transducer with input range of 1 to 5 ampere, output range of 4 to 20 milliampere, and the auxiliary supply 80 to 276 volt AC or DC. So this is basically a current transducer, and if this is our input auxiliary plus minus. These are our outputs. These are our outputs. This USB is for programming. You can program the transducer. These are your input signals. You can put the input signals here. Input signal. So first of all, let's connect our auxiliary supply. 110 volt DC. We will get the input signal from the sensor. It can vary 1 to 5 ampere, and here you can see we have two different output, A1 and A2, and we have plus and minus, and these signals will go to the PLC. Let's assume we have two PLCs, PLC1 and PLC2. So you can get two different same outputs. So you can take the 15 and 16 and fed it to PLC1 and 17 and 18 to PLC2. So I hope the concept of analog input and output wiring is clear to you. If any doubt, please do ask in the comment section. And in the next video, we are going to do analog input output, digital input output wiring in Siemens S7 1200 series PLC. You will get a clear idea of how to do that. So the next video is going to be very important. And also, if you like this video, please do like, share and subscribe, and also press the bell icon so you don't ever miss any update from us. And stay tuned for our next video. And the next video is going to be our last video on wiring. After that, we are going to start the programming of PLC. So stay tuned and take care. Thank you.